Hello everyone, I am Professor Nehal Ansha. In this video, we are going to study ring oscillator. Before starting, I suggest look at previous videos of CMOS inverter schematic as well as layout which are created in electric. In this video, we will draw schematic and layout of ring oscillator for 5 stages and identify maximum frequency of oscillation. We will also measure area in micrometer square. W/L ratio of NMOS and PMOS will be considered as 10/2 and 20/2 respectively. Similar process can be adopted to create ring oscillator of 9 stages or any number of odd stages. First of all, we will start electric. And we need to open our existing library where previous schematic and layout are stored. You can create new schematic for 5 stages. You can use already created schematic of inverter. First of all, open electric and open existing library file. In which schematic and layout of inverter are already existing. You can observe schematic is selected and in right pane you can observe schematic of inverter. You can create icon view using view make icon view. You can observe for our inverter icon is created with A as input, B as output and VDD as well as ground. You can also observe file with my_inverter icon is also created. Now we will create schematic for 5-stage oscillator. Schematic is selected over here. In schematic window, now drag icon of inverter. For 5-stage inverter, 5 times this icon is taken. Align all the icons properly and output of first inverter is connected as input of next inverter and output of last inverter will be connected as input of first inverter. On the output we will create export. where we can measure frequency of oscillation. Check DRC. If there is no error, create spice tag. Now we are ready to run simulation using LTspice. In LTspice, open your spice tag. You can visualize the sub-circuit of inverter over here. You can also observe that the same sub-circuit is repeated 5 times and inverter 0 to inverter 4 are created. Add VDD is VDD to ground 1.8 volt and perform transient analysis for 10 nanosecond. Do add trace. Select voltage at output and you can observe oscillation waveform. You can observe 2 peak represent 1 cycle, or from this minimum value to the next minimum value, that also can be treated as 1 cycle of oscillation. You can also observe from second cycle onwards, all these cycles are repeating in same manner. If we increase time of simulation from 10 to 20, we can observe more number of such cycles up to 20 nanosecond. By measuring 2 peak, you can find time period for 1 cycle. So over here, you can take your cursor to the first peak. You can observe your X is 3.45 nanosecond. Second peak, you can observe your X is 4.51 nanosecond. So the difference between them will give you time period for 1 cycle, that is T, and 1 by T will give frequency of oscillation. If we measure time manually, there could be measurement error. So instead of measuring manually, you can also add dot measure script in your spice tag. You can observe T1 is measured on output when output is 1.8 volt on second rise, and T2 is measured on output on third rise. Because we have observed that from second cycle onwards, all cycles are identical. That's why we have measured on second and third rise. The difference between T2 and T1 will give you time period for 1 cycle. We will run this script. Output waveform is same as before. View log. You can observe T1 is 3.428 nanosecond and T2 is 4.542 nanosecond. Difference is 1.114 nanosecond. Its inverse will give you frequency. So you can observe frequency of oscillation is 0.897 gigahertz. In megahertz, you can write 897.66 megahertz. Use similar process and measure frequency for 9 stage also, and then perform comparison between 5 and 9 stage. Thank you.